Hello, my name is Tanya Singh. Today I'll be presenting some topics about the hydrocarbon engineering, and these are diesel index, characterization factor, and vapor lock index. So, our first topic is diesel index. So basically, diesel index is just same as cetane number. Both denote the ignition properties of a diesel fuel. Just the thing is that the cetane number is calculated based on the percentage of cetane, which is a hexadecane kind of, in a combustible mixture having properties as same as that of diesel fuel tested, and diesel mix index is calculated based on the fuel's density and distillation range. The increase in both diesel index and cetane number indicates good quality fuel. The diesel index indicates the ignition quality of the fuel. It is found to correlate approximately to the cetane number of commercial fuels. It is obtained by the following equation, which is diesel index equals to aniline point in degree Fahrenheit multiplied by degrees API gravity divided by 100. So the diesel index and cetane number are usually about 50. Lower values will result in smoky exhausts. So now the point rises that what is aniline point? So basically, aniline point is defined as the minimum temperature at which two equal volumes of the sample and aniline are completely miscible with one another. This simplified method gives an indication about the extent of aromaticity of the fuel. Accordingly, a high paraffinic fuel will have a high aniline point since there is a great difference between the molecular structure of the aniline and a paraffin. The opposite is true for hydrocarbon contents and high aromatic contents. Such an aromatic is more easily soluble in another aromatic than is paraffin. Also, it has been observed that hydrocarbons of low specific gravities have lower aniline points than hydrocarbons with higher specific gravities. Thus, the specific gravity as well as the paraffinicity of the fuel. So, when the aniline point of a diesel fuel in degree Fahrenheit is multiplied by its API gravity divided by 100, which is inversely proportional to the specific gravity, then a value representing the real paraffinicity of the fuel is obtained. So now the another topic is the characterization factor. So the characterization factor is a measure of the aromaticity or paraffinicity of a crude oil or of a crude oil fraction. So the most important or two most widely used correlations are UOP or Watson characterization factor, which I have written in this particular box. KW is represented by Watson characterization factor, and CI is basically correlation index. So KW is equals to the TB raised to the power 1 by 3 divided by G, where TB equals to the mean average boiling point in degree R and G is the specific gravity at 60 Fahrenheit. Correlation index is also given there, which is equals to the CI equals to 87.552 divided by TB plus 473.7 G minus 456.8. So these are the formulas of Watson characterization factor and correlation index. So here I have shown the universal oil products, which is in short form UOP, or Watson characterization factor, which is represented by KW. So basically KW is less than 10 for highly aromatic materials and KW at the same time is almost at 15 for highly paraffinic compounds. The formula is already given there. So for crude oil, KW ranges between 10.5 to 12.9. 10.5 is for highly naphthenic crude and 12.9 is for paraffinic based crude. So here I have mentioned the formula of correlation index again, which is also termed as US Bureau of Mines correlation index. So low correlation index means high on paraffinic hydrocarbons and high correlation index means high in naphthenes and aromatic hydrocarbons. So our next topic is vapor lock index. So the vapor lock index, in short VLI, or in Germany volatility index, is basically a measure of the quality of motor gasoline calculated from DVPE and E70. So now the question arises that what is DVPE and E70? So the DVPE is the dry vapor pressure equivalent, which is basically the vapor pressure in kilopascal of gasoline or gasoline compounds, which is measured at 37.8 degrees Celsius, which is almost corresponds to 100 degree Fahrenheit. So now the question arises that what is E70? So E70 is basically the evaporated content at 70 degrees Celsius, or basically it is the percentage of gasoline in volume that has evaporated at 70 degrees Celsius. So, the vapor pressure is a measure of how many very light fractions, example butane or isopentane, contains a gasoline. So, it is as simple as that how many very light fractions contains how many gasolines. So, too high a vapor pressure in a gasoline leads to outgassing of these components, especially in summer. So this pollutes the environment and even can be dangerous. So the E70 is basically the measure of the light components such as pentanes or hexanes in gasoline, which I have told earlier too. So now vapor pressure and E70 are not independent of each other. A high vapor pressure suggests a high proportion of light substances such as pentanes or hexanes. A high E70 also causes an increased vapor pressure. The vapor lock index combines both qualities and is a measure of the starting and driving behavior when the engine is hot. So basically, the vapor lock index is calculated according to the given formula, which is VLI equals to 10 multiplied by DVPE, which is the dry vapor pressure equivalent, plus 7 multiplied by E70, which is evaporated gasoline at 70 degrees Celsius. The vapor lock index is usually more popular in US. So it is basically, in simple words, can be said as it is a measure used to control the tendency of gasoline to form vapor lock in most markets outside of US. So the measurement for VLI is calculated as per the given formula which I have mentioned above. So the typical values range from 800 to 1250, and lower vapor lock index is better. So in the countries, vapor lock is controlled by vapor liquid ratio rather than vapor lock index. Vapor liquid ratio is the temperature at which gasoline forms a ratio of vapor liquid to liquid volume that is equal to 20. So the normal range for vapor liquid ratio is 35 to 60 degrees Celsius, which is 95 to 140 degree Fahrenheit. So higher vapor liquid ratio is better. So that's all from my side. Thank you.